Good evening, friends. Hope you are all doing great. So, we started analyzing hospitality analytics, and the day one, we have understood the applications of machine learning as well as artificial intelligence with respect to hospitality analytics. And in day two, we have seen a CRISP-MLQ, which contains 6 to 7 stages, which is required for any data science project management methodology. So here we have used first business understanding, data understanding, then data cleaning or preparation, what we call it as data pre-processing, and then we have exploratory data analysis. Then we have model selection. Then we have deployment. And then we have maintenance and monitoring. Okay, so these were the steps that we follow for project, any data science project, that is CRISP-MLQ. Now, the portion of CRISP-MLQ, which takes 40% of the steps, that is EDA, which is very important to understand, where we do data pre-processing and data to be ready to fed into the model. So we have plenty of models like regression model, classification model, clustering model. So all these models accepts data in their own fashion. So hence we need to prepare this particular data to fed into the models. Hence we need to pre-process that particular model and try to understand what the data is talking all about. We just need to talk to data and understand what it is telling. Okay, and that will be your EDA. We call it as exploratory data analysis. Okay, so this is what exploratory data analysis we call it as. Now, what all things that will be used for the exploratory data analysis? We'll go in depth and then try to understand. When we talk about particularly for exploratory data analysis, we have several steps to be followed. First one is first moment business decision, second moment business decision, third moment business decision, fourth moment, and graphical representation. So more or the same, the graphical representation, we can understand the data, what it is telling. So if the data is huge, if the data is big, so we are not able to understand what the data is talking about. So we do go for some calculation process. So for that particular calculations portions, data need to be pre-processed, need to be cleaned. Okay, so we'll go one by one and try to understand. So first moment business decision is measures of central tendency, where we have mean, median, and mode. So whenever we have a numbers, numerical value, we can calculate the average value. We call it as mean. And the median value, you sort the element and consider the middle element. So that will be your median. So mode is the more number of repetitions. will be your mode. Okay. So in data science, we gradually don't use, or basically don't use mode. Somewhere in one or two steps we use this, but basically we use mean and median concepts. Where does this fit? Let's say example, I have 1, 2, 3, 4, 5. So we have this number and I left blank this and this, the last. Okay. So I've literally not made any attempt to make that element present. Now, when I calculate the total amount, it will be 5 plus 4, 9, 9 plus 1, 10, 10, 12, 13, 15. So it will be 15, 5, 4, 9, 12, 14, 15. Okay, 15. How many numbers are there here? 1, 2, 3, 4, 5, 6, 7. 7. Okay. So when I calculate the average, you will be getting 7, 2 point something. Okay. So let us take 3. So you are getting 3 value. So why we are calculating average? Just because you can see that you are having some missing values here. These are the missing values. Now, if I update with some value, let's say example 4. Now 1, 2, 4, 3, 4, 5 and 4. What will be your value? Total value. Your total value will be 2, 3, 7, 10, 14, 19, 23. So your 23 divided by 7. Okay. 7 4s are 7 3s are 3.8 or something. Okay. It will be 3.8 something. So whatever the 4 value I've updated, it is correct. Almost correct. Not you don't have anything beyond that, or it is not. So why we are updating some value here? Because the data should be balanced. You should not have any imbalanced or improper data or any missing values. When you have missing values, it will lead to inaccuracy. Your accuracy will go down. If something you are missing, your accuracy will go down, and it is not proper method to follow to use calculations with missing values. So to patch up or to update those places where it is missing, we'll use the average value. So at the end, when you calculate the accuracy, even including the number, even including the mean value, let's say example, I have taken 1, 2, 3, 4, 5. These are the 5 values. Now, what is the average of this? Average of this, it will be 3. Now, if I remove this, okay, if I remove this, purposefully I'm doing it. So what is the total amount? Why 5, 3, 8, 10, 11. So 11 divided by 5. So 5, 2 point something. Okay, let it be 2.5. Okay. So can you see that the missing value will be 4 and your value is 2.5. It is almost equal, almost not equal, almost nearer to that value. So there won't be any gradual change in the value. So if I update here, irrespective of number, let's say example, if I update my own number, randomly picked number, either 4, 5, 6, 8, 10. So when you update these random numbers without knowing, without understanding, you may vary with the accuracy value. So we follow some common method. Whenever we find a missing value, we update that place with some value without affecting the accuracy. So we should not affect any accuracy level, and then we need to update that particular missing value. So that is why we follow this mean calculation. And you can also use median. What is median? Let's say example, we have 1, 2, 3, 4, 5. It's already sorted. The median value is 3. Okay, so the middle element. First, whatever the series that you have, you sort that in ascending order and find the middle element. So that will be your always median. Okay, so that is the importance of mean and median. Now see here, 1, 2, 3, 4, 5. Now what is the mean value for this? It will be 3. Now what is the median value for this? It is 3. Okay. Now I'll give you one more. What is the mean value for this? 1, 2, 3, 33, 37, 42. So 42 divided by 5. So it will be 8. Okay, assume that mean value is 8. Now what is your median value? It is not sorted. 1, 2, 4, 5, 30. So it is 4. Okay, it is 4. Now, can you see this median and mean value? So mean value is 4, median value is 8. I'm sorry, I've written the other way. So median value is 4 and mean value is 4. So can you see that in this it is same? In this it is different. You have a variation. So when I check and when I see the mean and median value is difference, you can see that there could be a chances of imbalance or outlier of the data set. So here you have equal variation, that is 1. Here you don't have equal variation. When you don't have equal variation, this 30, whatever you have here, that will affect your accuracy. Okay, I'll give you a simple example. One example that in a class, there are 10 students, out of which all the 10 students have wrote the exam. So what is the attendance percentage? 100% attendance. Okay. So if I say out of 10, 8 students appear to the exam and your attendance will be 80%. Okay. Now you don't have here 2 people. So 2 people, one got fever and he didn't write, and one purposefully didn't write the exam. So when it is fever, you are not able to write the exam, it is acceptable. When you are not writing purposefully, this will indirectly affecting your percentage accuracy. You should get always 100% examination, that is result. If you are not getting 100%, from this fellow, the one who has not written the exam, is impacting the accuracy. Obviously, whenever you do changes to the data, you will be having some changes in the accuracy level. Okay, so when you have accuracy level got changed, that means there is someone who's changing that. So we call them as outlier. Those who are affecting the accuracy level, we call them as outlier, outstanding. So they're tremendously affecting the data, making it as imbalance. And when the data is imbalanced, your accuracy will not be proper. So there is one way of identifying first mean value, median value. These both should be almost equal. It should be almost equal. When we say it is almost equal, then you say that the data does not have outlier. If these two does not equal to, and you have more variation, more differences, more variation, more differences, then what you say? There exists outlier, which affects accuracy. The day we started to analyze the data, use that for a model and get some accuracy. We are all doing just because to increase the accuracy. That is our objective, whether it is regression model, classification model, clustering model, whatever the data is all about. At the end of the day, we need to have high accuracy level. If your accuracy level itself is down, let's say example 60%, what is the use? So you need to see to that there won't be any outliers that is affecting your accuracy. So to check whether the data exists with outliers, we check for mean and median. So this is one of the important step that we can check whenever you want to do with the data or clean with the data before pre-processing the data. This is one method. So hence we call it as first business moment decision. Now, when you calculate the mean value, you can also calculate the variance to check for the variance and standard deviation. Now, what does variance and standard deviation do? It will check whether the data is normally distributed or not. When I say the data is normally distributed, then I'll say the mean value will be 0 and the standard deviation value will be 1. So I know the curve, it is equally distributed. You can see that you will be always getting mean value 0 at the center, and you have these values equally divided. This place and this one will be equally divided. That means the data is distributed equally. So which gives variation and standard deviation. From the variation calculation and standard deviation, we get the values. So the range is also giving us from here to here. So this is my range. In this range, my data is equally divided. So always when you are going with accuracy level to find accuracy, the data should be equally distributed. That is normal distribution. You should have always normal distribution. If it is not, we have another approaches, different approaches to make it as, but there are few other methods to make it as a normal distribution. Now, this is giving you whether the data is normally distributed or not, which in turn does not affect the accuracy. Okay, so this is one important point that we need to keep in mind. So we also have one business moment decision, that is skewness. So this is also gives you whether outliers exist or not, and whether the data is normally distributed or not. So you can see that when I say the data is not normally distributed, it is something like normal distribution. This is normal distribution. Let's say example, sometimes you have a graph like this. So you will be having a graph like this. That means your mean value will be here. That means it is not normally distributed. You have so many outliers here. So we call this as outliers. So we call this as outliers. So this graph, we call it as skewness. So negative skewness and positive skewness. So this graph is referred to be as negative skewness. And this graph is called it as positive skewness. So if the skewness is 0, that means you'll be having center portion mean value as 0, and you'll be getting normal distribution. Data is normally distributed. So from the graphical representation also, you can mention what is outliers and what is the normal, whether it is normally distributed or not. So after skewness, you also have kurtosis. Kurtosis, which is negative kurtosis, positive kurtosis. So when I say the normal distribution curve is like this, you can see that the curve will be like this. Sometimes you also have a curve like this. Sometimes you also have a curve like this. See how long it is distributed. This is not equally distributed. It is not equally distributed. It is unequal. This is also unequal. It is also not equally distributed. Sometimes it is less distributed. It is more distributed. So these kind of positive and negative, this is positive and this is negative kurtosis, will leads to a abnormal distribution, not normally distributed. It is not balanced one. So we need to understand the data in various steps, whether it is balanced or not balanced, and whether it is normally distributed or not, whether it is having any variations, basically outliers, to check whether outliers are there. If you have outliers, you have different methods to solve that and then proceed. Okay, so hope you are getting this. Now, when you are representing with respect to graphical representation, you have bar plot, you have box plot, you have scatter plot, you have line plot, and you have histogram. So all these are well-known graphical representation for data science or data set. We can use a data set in data science that is helping us to understand whether the data is normally distributed or having any outliers or everything. You can just understand the data. So data understanding. So bar plot. So it is going to have this bars and tell that it is having some values, some range. Here, this is the value. So you'll be having this much of levels. So like this, you can specify and you can mention what are the values of X and Y. And next, you have box plot. So here, the box plot plays an important role where you will be having, this is your median and this is your first quarter and this is your second quarter. So whatever you find within this, it is something like this. So this is equal. normal distribution. So whatever you find between this will be like here. If the graph is something like this, so the box also will be like this. So small portion and this is a big portion. So this suggests us it is not normally distributed. So this is one kind of box plot which is able to us to understand graphically. Instead of doing all these calculations, graphically you can just use it. Scatter plot. So whenever we see a relationship between the data is in the call. When we plot with respect to two columns, related correlation between the two columns. If you have like this, what do you understand? So it means that there is no relation. There is no relation between X and Y. Let's say example, I have the point like this. Can you see that when I increase the X value, you are also getting increase in the Y value. So there is a relation between X and Y. Here also, when I keep on increasing the X value, Y value remains constant. That is also one relation. When I increase the X value, you are decreasing with the Y value. So there is a relationship. So whenever I change something with respect to independent variable, the dependent variable is also changed. Here, whenever I increase, sometimes it increases, sometimes decreases, sometimes remain constant. So it is unpredictable. So we can't understand from this. So this plot gives you understanding the relation between the features or variables. Okay, so this is what we understand from the graphical representation. So histogram. So here we also have one more that is very important, that is histogram. So here, let's say example, I have a graph. Okay, so this is a graph and this is a mean value and this is standard deviation. Okay, so we have for every now and then we have equal distributions here. Okay, so this is and this is in this range from 1 to, let's say example, from 0 to -1. This is -2 and this is -3 and this is -4. Let's say example 1, 2 and 3 and 4 and 5 and 6. So 0 to -1, what is the area that is covered under this? That means when I calculate this area, it gives always the probability. Why I'm telling probability? Because from here to here, it will be 100%. From here to here, the data is distributed equally and overall, that is 100%. Let's say assume. Okay. Now, what is the area that is covered here? Out of 100, what is the area that is covered? I need to calculate that. If I calculate that area, I'll get the probability. Out of 100, 20% area is covered. This also 20%. So this also 20%. So this also 20%. So you can see 80% it has been covered. Another 20 and 20 here becomes 100%. It becomes 10%. Let's say this is also 10. So 80 plus 20, 100. So I just need to calculate always with respect to the area that is covered. When I find that area that is covered, I'll be getting whether it is overallly having equally distributed or not. Now, when I give you this, let's say example, I have given you this, and I have one more. Okay, so in bar plot, I have written the same diagram, but here I have given the values. Okay, there I have given the individual values. Here I have given the value. You can see that you will be getting x and y value. So here, from here to here, I have two different values. Like here it is 10, it is 15. So from 10 to 15, there is a value. I'll be getting, let's say example, from 10 to 15 means 10, 11, 12, 13, 14, 15. Let's say assume that these are the 5 people. Okay, no, these are the range values. Okay, from 10 to 15, this is a range. Here you get the count value. Let's say example, I got 10. So from 10 to 15 range value, that is score, I got 10% of students who scored 10 to 15. Let's say example, we have 50 students in our class. 5 students, few students have got 50%. Few students got 60%. Few students got 70%. Few got scored 80%. Few got scored 90%. Few got scored 100%. In this, if I say 100% means two people. 90% means, let's say 15 people. 80% means 20 people. 70% means again 10 people. 60% again 10 people. Okay, 20, 30, 40, 55. Okay, 8 people. 8 to 10, 25, 45, 55. It would become 20, 55. Okay. Then I'll make this as 5. 8 to 10, 20, 40, 45, and this is 5. Okay. Now overall is 50. 50%. Those who are scoring 10, 20, 30, 40, 50. Those who are scoring 50%, they are getting 5 people. That means here you'll be having 5 people. So they are scoring 50%. And under 60%, when it comes to 60%, you'll be having 1, 2, 3, 4, 5, 6 or 8 people. So for every range of people, for every range of score, you will be getting a probability or the count that you are getting. So that particular count you will be finding. So it is always like for the given probability distribution data. So within using this particular data, you can go and calculate for everything: histogram, line plot, scatter plot, box plot, and bar plot. So when we have a data, you can easily understand what it is talking about. So we'll take that data and we'll try to understand. So here I'm considering the data. I'll show you the data, how it looks. You can see that the data looks like this. You have a total data, which is having is cancelled, lead time, arrival date, time, day, arrival. Like this, you have plenty of values. This consists of both numerical data, categorical data. So it's a combination of both the things. Now, how do you explore these things? How do you explore? How do you understand? How do you get the some solutions? So before everything, before getting your objectives, you just need to first understand and prepare your data. So data understanding, and that means exploratory data analysis. Exploratory data analysis. You need to analyze the data, what it is telling about, why it is 27, why it is 1, is there anything else, 2, 1, and so on. You have direct corporate T and TO, direct is there, categories are there, online TA is there, direct is there. Okay, so like this, it is showing why it is 0, what is the meaning of the 0, and you have 342 and here it is 7. What is it about talking? So we just need to understand what the data is trying to tell. So from that, we just need to understand so that we can use the appropriate model so that it will be useful. Okay, so we'll go with the EDA. So I'll come to this one by one whenever we use the models. Okay, so now as of now we do require only pandas. So we import pandas as PD. Okay, so to read the file, so I've showed you Excel file, right? That is in .csv format. So hotel_booking.csv. So we'll try to read that and save it as a data frame. So whenever I give data frame df.ed, it will list all the 5 rows. So you can see that 0, 1, 2, 3, 4. So 5 rows will be only distributed, like all the columns. You will be getting all the respective columns, all the columns, but whereas you will be getting only 5 rows. Head means by default, you'll be having 5 rows. Inside this, you can specify you want 10, you want 11, you want 12, you want 15, you want 20. You can just mention inside that. If you don't mention anything and just specify head, it will be 5 rows. If it is for head. If you give tail, then it will display the last 5 rows. Okay. So let's say example, you have 100 rows. Okay. So 1, 2, 3, 4, 5. And this is 100. So when you have given head, it will display these only these. But if you display tail, it will display 100, 99, 98, 97, 96, 95. So only this. So it will display for tail. So this is how we can understand, at least read the data. So data is integer here. Here the data is integer. This is also integer. This is categorical data. This is integer value. This is integer value. This is also integer value. You are having 0 also. So like this, you can understand the data. What is the type of the variable? Type of the variable. Now, what is the use of pandas here? Let me tell you, what is the use of pandas? Pandas is not only reading the CSV file. When it is reading, it is doing a lot of work. You have a columns. Okay, you have columns. What are the type of that particular columns? The type of the particular columns. What are the types of that? Types in the sense whether it is integer, floating, boolean, string, characters. We need to understand, right? Before doing any programmatic, we just define the variables of type something, whether it is integer, character, float, everything. Okay. So pandas is going to read and assign this particular hotel column is with respect to character. And this is with respect to integer. And this is with respect to integer. So like this, it will understand and it will keep ready. So once we use that and we read the data, after that, we'll describe the data. When I describe this data, I've told you, right? Description is given to understand how many rows are there, what is the mean value of that particular column, and then what is the standard deviation of that particular column, and what is the minimum number in that particular column and maximum in that particular column. Okay, so we can understand from the describe method. So this describe method will be in the Python package, that is the df data frame. Okay, under data frame you have a method describe that describes all this. Count, mean. So count is 11,000, 1,19,390 rows. You have that much of rows in this particular hotel booking data. Okay. So for that, next mean value of that particular column, the first column mean value is 0.37. So you will be getting mean value, standard deviation minimum only for numerical data. So you'll not be getting for this column. July you have. You don't get that. Okay. So describe will work only on numerical data and gets the value. Not for all the column. Okay. So now after that, we just need to understand the data type of that particular columns that is used. So when I type info, it will give information about data set. It will give you information about the data set. Hotel object is cancelled integer, lead time integer, arrival date here integer. When you have both wordings, we'll get it as object instead of string or character. It will get as a object. Why? Because string is also an object, character is also an object. So it works basically with respect to object because it will be easy for us to access from the memory. Store and retrieve. Store and retrieve from the memory, it will be good. So hence it is based on object and it is object type. So now going further, these are the object types. Now we just need to identify, as I told you, we just need to identify whether the data has any missing values or not. So in this whole data, let's say example, I'll show you this here. In this, can you recognize where is the missing one here? So will you be able to do that? Where, in which column you have? Again, you need to go back here. You can into search. So manually, it is quite difficult. It is impossible and it is time killing. So what I'll do is I'll just give, there is in the data frame, if you have null values, that means df dot is na sum. What does it give in the data frame? My data frame name is df. In this, if you have any null values, if the particular Excel cell, it is empty, then it will identify and it will give you how many of them are there like that. In that particular column, let's say example, I have written 3 columns, 1, 2, 3. Okay. So we have 3 rows. Here I'll update A, B, C. Now, in this particular column, how many null values are there? 2. In this, 2. In this, 2. So these details will be given by this method, df.isNA.sum. Okay. So in this column, you have three observations. That is 1, 2, 3. Out of 3, 2 is empty. 2 is null. Okay. So 2 by 3. What is the percentage? What is the percentage? Almost 60%, almost 80%, I can say. Okay. So almost 80% of the things is null value. So you are getting that percentage and giving you what percentage of value that you are getting. So is percentage, how do you calculate percentage? Total number of rows and the number of columns, number of empty. So for that, what you'll do, I'll just calculate what is the sum of that, that is total, and divided by shape. So when I give shape of 0, this will be your rows. When I give shape of 1, this will be your columns. So in shape, you have rows, comma, columns. Okay. How many rows and how many columns? We have seen 1,90,390 something rows are there. Okay. 17 or 13 columns are there. So your shape will be 1,19390, comma 13. So it is like this. So rows and columns. So shape of 0 becomes rows. Shape of 1 becomes columns. Now, after finding this, you will be getting the values. So in this particular column, so these are all columns. Okay. And their null values. You don't have any null values. So percentage of null values will be 0. Okay. So like this, if I change the values, you can see that 488, the country, in this you have missing values 488. Among 390, in this you have 488. When you calculate, you will be getting 40% or 4%, something like that. So you can just get what is the amount, what is the value. Okay. So it is 4%, not the 40%. So then you can analyze that 0.4% will be your percentage of that particular value. It should not cross beyond that. Okay. This is 4%. Now, the next column, going further, you can see that something company, 1,12,593. It is almost 1,12,593. We also have 1,19,390. You can see that between these two, I can get 94%. 94% of the data is null value in the company column. So agent also has 16,000. So it will be 13%. So like this, you will be getting the data which is having null values, the columns which is having null values. Now, what we are doing in that, out of 1,19,390, you, let's say example, country has 1,12,590. Let's say assume that we got this. In this place, you insert 0 because all these are categorical data. When I calculate this, you can see that agent, company, these are all categorical data. Country is also categorical data. Children is also categorical data. So like this, only for categorical data, you have missing values. So what I'll do is there won't be any issue which is directly impacting my accuracy, even for categorical data if it is 0. So what I'll do is I'll fill wherever you have not applicable. That is NA means not applicable. That means null value. Wherever you have a null value, you replace in place as 0. So every empty, before it was in empty. When you execute this fill NA, after executing, it will become 0. So now you don't have any null values. Okay. Now you can also represent that using graph. Okay, that is bar graph. So I'll just show you that. So you can see that. So you can see this. The hotel is cancelled. The percentage of. Okay, so what is the percentage of values that you are getting? The null values. Now, so let's say example, couple went to the hotel and they booked the room. Here, in the place of child, they don't have children, so they have mentioned it as 0. So 0 doesn't make calculations as 0 because they don't have 0. So they don't have children means it becomes 0. So again, it is categorical data. Don't worry. Don't think that it is numerical data. If you have 1 children, 2 children, 3 children, 4 children, 5 children, maximum 6 children. So you can update in a categorical data. 1 children, how many parents? 2 children, how many parents? 3 children, how many parents? Like this, you can have a categorical data. Hence, 0 is referred to be as categorical, not the numerical data. So we'll just calculate and filter if the children is 0 and adult is 0 and babies is 0. So we'll filter that and put it in a filter. Okay, so now we'll do that filter and then put it in a filter column. So you have a filter column. You can, where you have filter. Okay, this will be your columns, D of a filter. You can see that all these are filters only. So whenever you find the children 0 and you are using logical and then adult 0 and baby 0, those particular rows will also be under filter. So now we have one more data frame that is filtered, which is having no children, no adults, no babies. So this can be used for another purpose. So we have 180 rows and 36 columns. Now, excluding, I'm just saying excluding filter. So we are just avoiding which is having no children, no adults, no babies. So we should exclude them from the original database. That means you have universal. This is your data set. And you have a particular set which is having 1, 2, 3. So universal has 1, 2, 3, 4, 5, 6. Okay. Now, what is my B set? What will be my B set? You have 1, 2, 3. Next, it will be 4, 5, 6. Because whenever you compute A minus B, you will be getting A plus B. You will be getting 4, 5, 6. That is universal. When you have A, when you have universal, A plus B equals to universe, you will get B when you subtract universe, when you subtract A set from universe. So that is what we are doing. First, we try to analyze whether the baby is not there, adults is not there, and children is not there. We exclude that and we take only the rows which is having some values with the children, adults, babies, exactly. So that becomes whole family came for the hotel and stayed in a hotel. So excluding the filter, you will be getting a data frame. That data frame I need for calculations. So how many rows are there? So 1,19,210. Okay. So it was 390, right? Now it is 210. So 180 rows got deleted. Okay. So 180 rows got deleted. Now we need to understand country wise guessed, because we need to explore the data and analyze that. So we need to understand from which all country they book the hotel. From various countries they book the hotel. From, I just need to know which country is booking more, the people from which country they are booking. So for that we do have understanding country wise guest, that is df is cancelled equal to 0 country value dot counts reset dot index. So you have a two columns, is cancelled country. Whenever you have is cancelled equal to 0, equal to 0, then you take that particular country column and go count the values and reset the index. That means you reset this index saying that the country and number of guests. So I'll be getting only that particular country. Let's say example, I have France and number of guests 23. So I'll be counting this France every row and then adding that. So what I'll do is I'll just get the country and number of guests. You can see that you have PRT, GBR, FRA, ESP, DU, BHR, DAG, DGI, MLA. These are the country codes. So PRT means Portugal, GBR means Great Britain, FRA means France, ESP means Spain, DU means somewhere Denmark. So these kind of things will be given and the number of guests that has been booked. You can see from this, we understand that from Portugal, from Great Britain, France, Spain, all these they are booking, but most of them are from Portugal. What it gives an idea that they are booking more. So shall we give them a offer so that they'll attract towards some more and they'll come and book the value, book the hotel. So this is one of the strategy to understand who is coming more from where. So it gives us strategies. So exploratory data analysis gives you more number of strategies, decision making. So you can see that from the graph, you can see that the blue color from the graphical representation, you can see that blue color is 0, nil. When you move towards these colors, you can see that almost this color. So here it means that Portuguese, they are booking. Okay. So you can see that you can just try to understand from the graph. So that is a graph. And you can see that there are two things. One is hotel and one is resort. So resort and city hotel. So we can also understand how many are booking hotel, how many are booking resort. Okay, city hotel and how many are booking city hotel and resort. We can also understand when they are busy. So in hotel management, you have plenty of decision makings. We need to make more strategies. We need to predict whether the people are coming in this month. You have a business in this month. We have different strategies. You can see that whenever we get a holidays, we'll trip and we'll go some places and we'll roam and we'll stay there and we'll come back. Rest of the days we don't go. So during that occasions, the people go roam, stay, and then do business. So which all month you have occasions? When I say I'll get the business, that is profit. If I check the column profit, you'll be having more profit in the month of summertime. In the month of summertime, that is March, April. And in Jan, Feb, March, Jan, July, August, you don't have any business. And then again, September, October, November, you have business. December, Jan, Feb, you don't have business. Feb, March, April, you have business. So like this, based on the occasions, you can design. So that graphical representation, we get the from box plot. So this is my box plot. Okay. So that gives you box plot. And after that, you have the arrival time of the people, when they are coming, how many days they are staying, when they are going back. So all the histories, all the columns that will tell you with the data. So once you have data, analyzing that data, you can see that arrival month is April, August, December, February, January, July, June, March, May, November, October. So considering whole thing, I just need to analyze which is best one, which is having good profit, which is doing business. So even this with respect to city hotel, this is with respect to resort. Okay. So I just need to understand finally whether the people are booking city hotel or uh, resort. So I can from the data, you can see that in a month of April, more people are going for city hotel. In the month of August, more people are coming to resort. In the month of December, more people are going to city. In the February, more people are going to city. January, more people are going to city. July, more people are coming to resort. So in the month of August and July, the people are opting for resort. So that price prediction can also be done with the help of this. Okay. So this is tells you the data analysis. We call it as data analysis. So this is one of the final price that we calculate for every month, and then we'll do a graphical representation for the same. And for resort, how many guests will come every month, and for city, how many guests will come, that is also there, and final guest. So this all gives you exploratory data analysis. So only using this graphical representation and doing some analysis over the data with our own strategies and understanding the data will gives you more idea. So this is all about with respect to exploratory data analysis, which we are supposed to do with respect to data. So tomorrow we'll try to understand how this model is going to learn from the data, how this model is going to react for the data. We take the same data and fed into the some model. So what model? We'll use some regression model, we'll use some classification model. So how it is going to helpful for predicting something, how it is going to give some strategies, how it is going to make some decisions. So we'll see that and we'll try to understand that. Okay. So this is what we'll see tomorrow. Thank you, friends. Thank you for attending. Please do subscribe for the channel and get more updates.